Just before midnight, on April 12, 1977, Delta Flight 1080 was preparing to leave San Diego for Los Angeles. The Lockheed L-1011 was carrying 41 passengers and 11 crew members, and its 3 engines were operating normally. Captain Jack McMahon was at the controls. As the aircraft accelerated along runway 27, the takeoff initially felt routine. At about 125 knots, the aircraft lifted off with little or no control input. Then the pitch-up continued. McMahon pushed the control column forward, but the response was far smaller than expected. He checked the stabilizer setting. It was correctly set for takeoff. The aircraft was climbing, yet the controls were not giving the crew the authority they expected. For the moment, they had no explanation, and no cockpit indication telling them what had gone wrong. McMahon kept pressure on the control column as the L-1011 climbed through 400 feet. The nose continued rising, eventually exceeding 18 degrees. He tried the electric pitch trim, then the mechanical trim wheel, but neither gave him the response he needed. The stabilizer indications showed full nose-down trim. That was the first major clue. The aircraft was demanding more nose-down authority than its normal controls could provide. Flight engineer Stephen Height checked the hydraulic systems. Their indications were normal. The crew reset the relevant trim controls, checked circuit breakers, and exhausted the available procedures for a trim, pitch axis, or control path problem. Then another problem appeared. During a turn, McMahon found himself hitting the stops in roll control while trying to maintain a right bank. Something was pushing the aircraft left, as well as forcing its nose upward. By 3,000 feet, the crew had no warning light, no obvious hydraulic failure, and no explanation for why the aircraft was refusing to follow its controls. The crew's first attempts to correct the problem were not working. Worse, the aircraft was now climbing as its nose continued upward. By 4,500 feet, the pitch attitude had passed 22 degrees and the airspeed had fallen to around 140 knots, only slightly above the aircraft's V2 speed of 138 knots. McMahon and Radford were both pushing fully forward on their control columns, yet the aircraft continued upward. They needed to prevent a stall, but the normal method, lowering the nose, was already unavailable. Then McMahon noticed something that could change everything. Thrust was affecting pitch. He abruptly reduced thrust on all 3 engines. The aircraft's pitch changed slightly. He then advanced the center engine while adjusting the wing engines to maintain airspeed and counter the left roll tendency. The nose began to drop. It worked, but only partially. Now the crew had discovered something important. Engine thrust could influence the aircraft's attitude when the normal pitch controls could not. By now, Flight 1080 had been stabilized around 10,000 feet, but only within a narrow window of airspeed and thrust. The crew had discovered a workable combination, yet they still faced the hardest question: where could they land? Los Angeles offered their best option. A long, straightened approach to runway 6R would keep the aircraft over the ocean and give them room to manage the control problem. The crew chose lax. They planned a high-speed approach with reduced flap settings because a normal landing configuration could make the aircraft difficult to control. As they descended, they changed the configuration one step at a time, checking the limited pitch response after each change. At 2,500 feet, they extended the landing gear. The aircraft suddenly pitched up again. McMahon pushed the control column fully forward, but the aircraft continued climbing and the airspeed began falling. Once again, he increased thrust on the center engine and reduced thrust on the 2 wing engines. Slowly, the nose dropped, and the aircraft returned toward the glide path. At 700 feet, they broke through the clouds. The runway was directly ahead. There was no normal flare to rely on. McMahon would have to fly the aircraft onto the runway at roughly 165 to 170 knots, with only limited pitch control remaining. McMahon kept the aircraft aligned with the runway using differential thrust. The engines were now acting almost like substitute flight controls, allowing the crew to make the pitch and roll corrections that the normal controls could no longer provide. At roughly 165 to 170 knots, Flight 1080 touched down within the first 1,000 feet of runway. But the emergency was not over. The main landing gear touched down, yet the nose would not come down. McMahon pushed the control column fully forward, but there was still not enough pitch authority to lower the nose wheel. He had to use braking on the main wheels to bring the nose down. The aircraft slowed safely. There were no injuries. But the mystery was not over. After landing, engineers examined the L-1011's flight control system. They soon found the problem. The aircraft's left elevator was jammed in the fully-up position. That explained the violent nose-up tendency the crew had been fighting since takeoff. The failure was associated with the left elevator's aft drive quadrant and bearing. Water had entered the mechanism over repeated pressurization and depressurization cycles, causing severe corrosion. The bearing eventually failed, leaving the elevator jammed in the position that forced the aircraft upward. There had been no cockpit indication, specifically warning the crew that the elevator was jammed. And in the darkness, there was no practical way for them to see the stuck control surface. The crew had not been fighting a conventional hydraulic failure. They had been trying to control an aircraft whose left elevator was physically stuck. Yet before they understood what had failed, they had discovered something that kept the aircraft flyable. Differential engine thrust could substitute, at least partially, for the missing pitch control. Flight 1080 had landed safely. The pilots had pushed the controls down. The aircraft simply refused to follow.